Thank you all for attending. This is VSP2757, deep dive on virtual distributed switching and the Nexus 1000v. Appreciate everybody coming out. I know it's the last slot, the last day, but thank you for coming here, sitting here and waiting on your earlier flight. So thank you for that. My name is Jason Nash. I am the data center principal for Vero. We are a really great data center focused partner in the Southeast, and if you can't tell already, I'm from Charlotte, North Carolina. So unlike most Southerners, I've been accused of speaking really fast at times, and we have a lot of material to cover. So excuse me if I do that. It's just a habit that I have, and I would love to do this session as a 2-hour session and get twice as deep on some of these technologies. But it is what it is. So we'll go ahead and get started, since I said we have a lot. So the purpose of this session is to really give you kind of a compare and contrast of your virtual switching options. So I get this question a lot when I work with customers. You know, they're probably on VSwitches now. They're looking at upgrading functionality in the virtual networking environment. So they come and ask, do I do the vSphere distributed switch or do I do the Cisco Nexus 1000v? And for a lot of people, it's a feature comparison, checkbox comparison. And I always want to stress and talk about there's more things to it than that. And even on the feature comparison, a lot of things aren't simple checkboxes. You know, one thing that the VDS may do, the Nexus may do it at a slightly deeper level. And while to a server admin they may seem very similar, to a network admin or a Cisco person, it's vastly different. So I just want to kind of walk through some things. We're going to start talking about features very quickly. We're going to talk about cost. We'll do a comparison on complexity, and that's one that I like to talk about a bit, especially depending on who's going to be deploying and who's going to be managing the virtual switches. And then, how do you deploy and how do you manage each of the two options? So first, we're going to cover the new vSphere distributed switch, and excuse me because they've kind of settled on vSphere distributed switch for VDS, and I always say virtual distributed switch and all sorts of things, so excuse me if I keep changing my terminology. And then we'll look at the Nexus 1000v. So my goal is to show you, or at least hopefully get you to see how you can use these in your environment and which one is a fit for both technical reasons and organizational or management reasons. And so I wanted to do a live demo. I have done this session in other venues where I have my lab gear right here, and I do live deployments of both, and we walk through configurations. Unfortunately, that's a lot harder to get done here at VMworld, so I've done videos, and I'll talk over the video as they run. I don't like to do canned audio videos. That's a little bit too much. But real quick, let's talk about the standard option, your standard vSwitch. We're only going to do one slide on this. You know, we've been using these for a long time, and a lot of my customers still use standard vSwitches. And we do it for a couple of reasons. One, they may just be on Enterprise, not Enterprise Plus licensing, and that just may be what they want to do. But we also use them because they're easy to understand, well-documented, well-tested. Most everybody knows how to manage them, and they're easy to troubleshoot. And also, you can do some really funny things with them. You can do all sorts of crazy mixed configurations, and part of my cluster set like this, and part of it set like that. Whether you should do that or not, it still lets you do those things. But they're also, you know, not all great. If you notice, when vSphere 5 was announced, there's really no features added to the standard vSwitches. Everything cool is on the vSphere distributed switch. They're also cumbersome as you spread out, get more port groups, especially as you start doing other virtual firewalling and load balancing and edge deployments and things like that. They get extremely cumbersome. So we've started to migrate away from those en masse. So you have two options. So if you say, okay, my standard vSwitches aren't covering it, I need to move up and do something else. So you have two options. The two options you have are vSphere distributed switch, and I'll talk about some of the features in 5, and the Nexus. With the release of vSphere 5, the VDS moves up on the feature list. And so it stacks up fairly well at a basic feature level to the 1000v with some minor differences. You know, things like NetFlow. We now support NetFlow in the VDS. How many people here use NetFlow in their environment? Okay. How many people here use NetFlow version 5? How many use 9? I love this question. How many don't know what version you use? There you go. If I asked that at Cisco Live, I wouldn't have anybody on that last one, but it just shows kind of the cross-pollination of you know, technologies. So NetFlow 5 is supported in VDS, 9 in the 1000v. To someone who's a server admin, there may not be much difference. To the network admin, there could be a ton of difference. Port mirroring. I can now do port mirroring traffic in and out of one VM on the VDS and dump it over to another VM or out a physical uplink. So now we can do port span or packet sniffing or whatever you want to call it, which is great in the VDS, but it's even more enhanced in the 1000v. 802.1p QoS tagging. We've kind of had this, with network I/O control. We tag frames now. We can do shares. We can do limits. We can do network resource pools now, so we can split out VMs in different resource pools instead of lumping them together. But again, on the 1kV, we can do some more advanced, queuing and tagging. So it's not always a very simple comparison. So first, we're going to jump into the new vSphere distributed switch. It's good because every time they make revisions, VMware's adding features. So we originally got network I/O control, which is now more advanced in 5. Again, I mentioned network resource pools. We also get things like load-based teaming, which I think is very cool. If you haven't seen load-based teaming, it's a really great way to channel your NICs together in a very simple way and do actual utilization management. So if a NIC sits at 80% for too long, the vSphere will actually move VMs from one link to another and actually try to do some active load balancing. It's also very low complexity, and you'll hear me talk about complexity several times. Everything's managed through vCenter. Everything is already in your vSphere host. You do simple deployment with a couple of clicks in vCenter, nothing else to manage, nothing else to deploy, no other components. And if you're an Enterprise Plus customer, you've already got licensing. There's nothing else to buy. The bad, and I just mentioned most of them, is the things how it stacks up against the 1kV. And I don't know if I'd call it bad, but if you need the features, you need them. NetFlow I mentioned. The 1kV does access control lists. So if you want to do basic ACLs within the switch, you can absolutely do that. The Nexus also has a feature set called vPath. vPath is really neat. It basically makes the Nexus 1kV and the piece of software we'll talk about on each vSphere host more intelligent. So with, say, vShield app or vShield zone, if I want to deploy the firewall, I end up putting service VMs across my entire cluster. With 1kV, to do similar things with, say, the virtual security gateway or the new virtual ASA that they're showing downstairs that'll be released next year, I deploy one service VM or appliance somewhere, and everything is managed by the vSphere host. The policies are sent down to the host, and everything's managed, and the decisions are made there. So I'm not using as many resources. And there's also some other security features you get on the 1kV, like ARP inspection, DHCP snooping, things like that are kind of, we get a request for those a lot when we're looking at VDI, and they want better port security. A couple of considerations when we start talking about how we deploy a virtual distributed or vSphere distributed switch. First of all, it's controlled and managed by vCenter, which I think is a good thing. It's simple. It's easy. But in the past, I've had customers who consider vCenter to be disposable. I don't do a lot of resource pools, or I don't need my logging, or I don't need this. So if it blows up, I just build another one, add my host, build my clusters, and I'm good. That's a little different when we start talking about these switches, and really it goes across both. So you need to make it more resilient and treat vCenter kind of as a tier 1 application. Virtual vCenter or physical? I don't really care. VMware doesn't care. It's supported either way. You can run everything, all your management, all your NFS, all your iSCSI vMotion through a virtual distributed switch. But you just kind of want to make some things and think about it. We'll talk about a few things you need to worry about later on in the session. And then if you're in an environment where you may have a mixed mode cluster, I have a cluster that supports DMZ networks and production networks, or things that are under PCI and not under PCI, or whatever. We need to look at how you can separate that traffic. It's also very common people want to have dedicated NICs for iSCSI or NFS. We kind of have to talk about that because it's not always straightforward how you do that with the VDS. So deploying the VDS is very simple. I've got the steps, and we're going to walk through them in a video, but everything is done through vCenter. You basically go into the inventory networking, right-click, and say, I want to deploy a new switch, and it asks you a couple of questions, and you're off and you go, and then you start building your port groups out within vCenter as well. So let's go. Now, I've done these videos twice this week, 2 different sessions, and I've yet to do it without messing one of them up. So let's see how this goes. So if vCenter, we go up to inventory, we go to networking, we right-click, and we say new virtual distributed switch. Really simple, right? So the first question it's going to ask you is, what version do you want? Well, that's a weird question, but it's not. So you may have a mixed cluster, and it wants to know, or for some reason you may want to support a back level because you may bring up an older revision of vSphere. So depending on which version level you pick, that denotes which features you get. If you want network I/O control, then you need to make sure and pick like 4.1. If you want the new stuff like NetFlow and port mirroring, you have to pick 5.0. What if I pick 4.1 now and next week I change my mind? It's easy. You just go into the main screen for the VDS and there's an upgrade button and you just upgrade to feature level. As long as your hosts support it, off you go. So that's the first thing that you need to think about. Always deploy the latest if you can. Take the features, take the upgrade, but deploy the latest. Then it's going to ask you another simple question. What do you want to call this thing? So what do you want to call the switch, and what's going to be appended to the port group names in vCenter? Pick a name that's relevant to you. The purpose. If you do multiple deployments, pick the purpose, pick the cluster, pick the location. Make it relevant. And then it's going to ask you how many uplinks do you want. So this is asking you how many physical NICs maximum do you expect to roll into this switch on each of your vSphere hosts. By default, it's 4. If you have 6 and you're going to use them, make it 6. Why don't I just make it 50? This is one of those things where I always ask this question, why don't I just set it to 50? And someone from VMware always says, well, the more you use, the more memory it takes. Okay, how much memory does it take? I don't know. Nobody ever knows, right? So here's the thing. You can change this at any time with 0 disruption. So pick a reasonable number. You can always change it later. There we go. So I named mine Nash Corp. So that's what I named my lab. And I believe I left it at 4, and off we go. Next, hey, do you want to go ahead and roll any physical adapters over? So you can deploy this thing, roll your hosts over, roll your VMs over, all in one simple wizard. And one thing I want you to see, I believe I do it here, is that I choose, yep, I do it later. Nope, I don't. So you pick a host and you pick the adapters that you want to move over. Then you say next. And then this question pops up, which is, do you want me to go ahead and create your first port group? This annoys me, right? Because if you look, the name is DV port group. That is not descriptive, okay? The other thing is, it doesn't let me set a VLAN tag. So I get a name that I don't care about and a 0 VLAN tag. So almost always, I'll uncheck that box and let it go ahead. I'll pick it later. It's easier to create one than it is to go back and edit this one. So it'll go and deploy the switch. Your switch is deployed. That's all there is to it, to deploying a new DVS. So it's very simple. And if you go and you click on it, you can look at the Summary tab. And one thing I want you to pay attention, because I'm going to reference it later, which it shot by, but is, told you I messed these up, is that it lets you manage and create port groups from the main VSwitch summary screen. When I show you the 1KV later, you're going to see that you can't make changes from vCenter. I just wanted to show you those in comparison. So now that the switch is delivered or deployed, we need to configure the main switch. And there's not a lot of stuff to set on the main switch. Most things are set at the port group level. But we do things like names and number of uplinks, which we just saw. Private VLAN designations. How many people here use private VLANs? Okay, that's the least of the 3 sessions. Interesting. NetFlow collector information, port mirror sessions. If you're using jumbo frames, this is where you bump up the switch-wide MTU, and then you set it again on the port group. And discovery protocols such as CDP and LLDP. So we'll run through this real quick, and I'll make some comments as we go. So again, you right-click, you go into the switch, and you say Manage this switch. One thing I want you to see here is Edit Uplink Names. Now, we said 4 uplinks when we deployed this switch, and now we can rename them. It gives them a very descriptive name. You would think VMware hired me to name this stuff because I have no imagination, and it calls them DV Uplink 1 through 4. What if I want to dedicate 2 NICs to iSCSI? Why don't I name those iSCSI, iSCSI 1, iSCSI 2? Or if I want to do it for DMZ, DMZ 1, DMZ 2. So make them descriptive, and later when we go do some things with them that I show you, you'll remember which ones are which, and you don't have to keep a spreadsheet somewhere, and somebody who comes behind you doesn't have to figure it out. So go ahead and name these things to be something descriptive. You can also rename the switch right here up at the top. So if you don't like that name, you can rename it. So we hit OK. We can do things there. Under Advanced, that's where we set MTU to like 9,000 for jumbo. If you use CDP or LLDP for neighbor information or link information, you can pick which one you use, and if you want to send and or receive, you choose that there, as well as some standard information. Network adapters just show hosts that you've rolled in. Private VLANs. So if you deploy private VLANs, you have a main VLAN and then a community and isolated VLANs. And I'm not going to do a PVLAN class, but for the overall switch, you have to define these here, and then you add port groups to them later. So you come in here and add the main VLAN, then you type in a couple more. It's a very weird user interface, and you type the number in, and then you say community or isolated. And those will show up later when we start configuring port groups. NetFlow, if you use NetFlow and you have a collector, you give it the IP of the collector and an IP for the switch to use so it shows up in the collector as that IP. And finally, port mirroring. So any port mirroring sessions are done at the main switch. So in the port mirroring sessions, you can say, hey, I want to mirror traffic from that VM to either another VLAN, or another VM, or a physical uplink and let it get captured on the physical switch. Nice thing is you can go into the main switch and set up 20 port mirror sessions and disable them all. And then when you need to check an application because it's something you commonly get a request for, you just go in and enable it. So you can preset all those, pre-stage them, and then you can enable them. So it's pretty handy. Here's something that's a little bit confusing, and it's going to get probably a little bit more confusing or hopefully clearer when we talk about the 1000v. Uplink configuration. An uplink is the configuration on the physical NIC of the server. It defines which VLANs we're going to trunk from the physical switch down into the vSphere host. It's also going to do some things like NetFlow status and allow you to block ports, but mainly it's all about which VLANs we're trunking. So the VDS lets you have one uplink configuration. What I mean by that is that when I create this, I say I want to trunk all VLANs, or maybe 5, 10, 15, 20, through these connections. I can't say I want these two NICs. I can't create two uplinks, one uplink for DMZ VLANs and one uplink for prod, and say these NICs go here and those NICs go there. I can do that with the 1kV. I can't do that here, and it becomes an issue when you want to separate traffic. So you have two ways of partitioning traffic. One way is if you want to use a single VDS. I can go into each port group and say, these NICs are active, these NICs are standby, these are unused, just like you do with vSwitches today. So if I have 4 NICs, 2 I want to use for iSCSI and 2 for VM, I go into the VM port group, set the 2 NICs for VM to active, the iSCSI ones to standby, or unused. And then I flip that on the iSCSI port group. The other option is multiple vSphere distributed switches. You can absolutely deploy multiple vSphere distributed switches. A lot of people look at me funny. They don't realize you can do that. Absolutely. You can even deploy the VDS and the 1kV in the same environment. So this way, I have one uplink for VM traffic in the uplink configuration set for those VLANs, and another VDS for, say, iSCSI and set for those VLANs. Which one's better? It's really up to you. I'm a fan of multiple VDSs, especially if you have a lot of port groups and a little bit of a crazy configuration. To me, somebody coming behind me, if I get hit by a bus, it's easier to figure that out because I can name the VDSs correctly, name the uplinks, and it's just cleaner. But again, it's completely up to you. They both work very well. Creating port groups is really simple. You're going to get asked a few questions, and then you're going to need to go back in and edit a few configurations. Sorry. So you're going to set a couple of things, and then we'll jump in. It's easier to show it in the video. A name, the number of virtual ports, and you'll see this again in the 1kV. So you set the number of virtual ports. This means how many VMs NICs can I plug into this port group. By default, it's 128. When I try to plug in that 129th VM, I'm going to get an out-of-port error, and people freak out. Well, you just come back to this field and up that number, hit enter, and it's non-disruptive. So why don't I set it to something larger? Because the more you pick, the more memory it uses, and there's an upper limit. How much memory does it use? I don't know. Nobody will tell me. But it's the same thing. But the limit is, it used to be 9,000, and now I think it's 20,000 total ports across the switch. So just don't go crazy and set them all to like 2048. Do something like 256, and if you need to bump it, do it from there. But don't go crazy. You're going to hit an upper limit. And finally, you need to tell it who is tagging VLANs. So there's a drop-down box with 4 options. It's pretty simple. Most of the time, when a physical switch sends a frame down to the vSphere host, we let the physical switch tag it, right? Everybody shake their head yes, because that's what you should probably do. So we let the physical switch tag it, and that way we set things to the VLAN, the second option. So when the VDS sends up a frame out, he tags it, and the switch sees it. We don't let the VMs tag it. We don't send untagged. That's normally what we do. But you can do other configurations. You can set it to none, which means the physical switch is going to tag the frame. That just means you've plugged your vSphere NICs into access ports on your switch. Nothing coming out of that switch is tagged. So the only thing it's carrying is one VLAN. The other one is VLAN trunking. I can trunk multiple VLANs to my VMs. I set it to VLAN trunking, I give it a range of VMs, and that's what gets passed up and back to my VMs, and hopefully your VMs have a special NIC driver that is capable of handling those different VLAN trunking and tagging. And finally, private VLAN. Remember I said we'd talk about this. The last one is you can then define this port group into which isolated or community VLAN you want it to plug into. 9 times out of 10, you're going to pick the second one there, VLAN, because that's basically what all we do when we set a VLAN tag in a vSwitch. Make sense? All right. Port group, most configuration is done at the port group. Most of this you've seen before if you've ever seen a vSwitch. Some new things are resource allocation for network I/O control and port binding type. Port binding type I'll talk about real quickly. When a VM gets plugged into this switch and powered on, he is assigned a port number, a DVS port number. And it kind of grabs them randomly, it seems, but it picks a port number. Static. Static means the VDS hands it a port number, and it has it for life until you delete it. Dynamic means when the VM boots up and connects, or you just click the connect box, it then asks the VDS for one, and then it gets a port number. Problem with that is, what if vCenter's down, and I can't get a port number? Sometimes that can be a problem. The last one is ephemeral, which means the VDS doesn't assign them. It's kind of like the local vSphere host assigns them. The problem here is that if I vMotion a VM from one vSphere host to another, the DVS port number will change, and I lose all my statistics and tracking. So normally what my recommendation is always set to static, especially if you have a virtual vCenter. There's only one downside to static. That's if you're in a really weird configuration where for some reason I can't raise the number of DV ports in a port group. I got to leave it at, say, 128. But I have 150 VMs where some of them go up and down, but I never have more than 128 NICs online, so I got to keep a water level below that number. Just leave it as static is my recommendation. There's really no reason outside of a couple of real weird use cases to do that. And static is the default. The last one is load-based teaming. I talked about that a little earlier, but it's also called load balance on physical NIC load, and we'll see it in a minute. But that is where we can take different NICs, connect them to different switches, and it does basically hashing on source MAC address like we've done a long time in vSwitches, so we can do it with non-stack, non-VSS switches, but it looks at NIC load. If this NIC gets too heavy, it'll move that MAC address for the VM over to this one, which is less used. So you get active load balancing, and you don't have to have any fancy switches or configuration. So that's my recommendation is use that. It works really well. So let's quickly run through this. And we're going to do a quick port group creation, because I'm already running tight on time. So we give it a name. We're going to raise the port number value. I usually do like 256, and I left it. And then I'm going to say VLAN, and I'm going to tag it as VLAN 10. So that's all you do to create a port group. Then I'm going to go back in, right-click, and edit that port group. Here we can do things like change our binding type. So if you want to go back in and change it to dynamic, that's where you do it. And you can, again, change this on the fly. Then we have policies like security policy, promiscuous MAC address, things you've seen in vSwitches. The VLAN type, and right here, route based on physical NIC load is how you enable load-based teaming. So that's all you have to do. You can have 8 NICs to 8 different switches made by 8 different people, and it'll just work and balance between them. Very simple, very easy. You don't have to call VM tech support. And then we have our active standby unused. So I said if you want to use one VDS and physically separate traffic, this is where you can move those up and down per port group, and why I said you should probably name your uplinks to something that makes more sense. Then at the bottom, we have net flow information, some basic things. If you want to block all ports for some reason, you can do that there. Something I've never really used. But that's it for port groups. Yes. Yes. And I don't get into that here as much as I can at one of the other sessions I talk about, but there's some best practices for enabling things like port fast, BPDU guard, and BPDU filter global on your switches, but absolutely. The question was, do I need to enable something like port fast because I don't want something weird to happen on the switches and cause a problem? And the answer to that is absolutely. So the last things you need to do on a deployment are move host to the virtual distributed switch, and then move your VMs. And we can do that in one easy motion. Pay attention to this because it's pretty much the same as a 1KV, and I might have to speed through. But you go to the switch, you go to the host tab, you right-click in the white space, and you say Add Host. And all you're going to do is pick the host, and something I want to show you here. And over here, I'm clicking there, but you can't really see that in the video. But there's nothing that comes down when I click Uplink. Why? Because I can only create one Uplink type on the VDS. So we'll continue on. I pick the two NICs I want to roll into this switch. Then if you want me to move over my VM kernel interfaces automatically, I choose which ones I want, and then I pick which port group I want to drop them in. So as long as this is configured correctly and your VLANs are correct, you can completely roll a host over to a VDS all NICs at one shot. No problem. Then you can migrate VMs. We can pick and choose which VMs, which NICs, and it'll go ahead and do the change. So there's the NIC, drop-down box, and VLAN 5. If you don't do this here, there's a wizard that'll do them en masse within the DVS summary page. And that's it. And so what it's doing is it's taking those two NICs we picked on that vSphere host, applying the uplink profile we gave it for trunking those VLANs, then it's moving the VM kernel interface to the port group we created, and the VM's NIC to the port group we created. And once that's done, that host is completely over. So if you're smart and use maintenance mode, you can absolutely deploy these in the middle of the day with no disruption. I've done VDS and 1KV deployments in a production environment, no problem. So a couple of best practice recommendations. I already mentioned it. Use static port binding if you can, unless you have some weird configuration. Try and let physical switches do all the tagging. I'm not a fan of native VLANs. I tag everything, all right? Everything going in, everything going out. It just makes things simpler. And finally, recommended to use load-based teaming. It's simple, and it works everywhere. You can do some things like route-based on IP hash if you have stacked switches or VSS and things, and you're going to different switches because that makes more sense for load balancing your applications. But most people I see, they really don't go that way. They would just rather have this and actually move VMs around as needed and take more advantage of a NIC. I know there's network people in here who are like, yeah, but if I have a lot of hosts and servers and I can split, and you're absolutely right. If you wanted to have more than one connection of throughput, then you may want to do something like IP hash. But for a lot of people, load-based is a great thing. So let's flip over 32 minutes and talk about the 1KV. Why? Because I saw how easy the VDS was. It's simple. It's easy. Why would I want to use 1KV? Well, we talked about the more features, and it feels and manages like a Cisco switch. It runs NXOS, which is the Nexus operating system, which is, if you're an iOS person, is very similar to iOS. So a lot of people feel right at home. It integrates with other offerings, such as vWAS, the virtual WAS appliance, VSG, the virtual security gateway firewall system, and the new virtual ASA, again, that they're showing downstairs in the Cisco booth. But why doesn't everybody just use it? Why don't I just deploy that then and get all these features whether I need them now or later? Well, first of all, it's cost. You're going to get charged to go up to Enterprise Plus, and then you got to pay a per socket license to deploy the 1000v. So if you have 20 hosts 10 hosts in a cluster, 2 sockets each, you're going to buy 20 sockets worth of 1000v licensing, right? It's not that expensive, but it is an extra cost. Complexity. You deploy things outside of vCenter. There's external components that must be deployed and managed. It's not all in a nice little bundle with vCenter. And management. That's not true, by the way. I didn't get time to change that. Most of the time, people manage it via CLI, but Cisco has DCNM, Data Center Network Manager. That is a nice GUI system to manage this. It's very inexpensive, so that's not entirely true, but most of my customers are still doing CLI management. I do CLI management. I don't know. I'm not a GUI guy, but whatever. Architecture. How many people here have ever seen or messed with or touched a Cisco 4500, 6500 Catalyst chassis switch? A lot of people. All right? If you understand basic understanding of that switch, you've got a lot of what this is about. So in a chassis switch, a Cisco switch, and really anybody's chassis switch, but I use Cisco terminology. In a Cisco chassis switch, you have basically the supervisor modules, the brains of the operation. You normally have 2 for redundancy. In this, we have virtual supervisor modules. They're like supervisor modules, but I can't really touch them. Okay? So you have the VSM. You also have, in a Cisco physical switch, you have some sort of network modules. In this, it's all Ethernet, right? We don't normally do token ring into a vSphere box, but you have virtual Ethernet modules, VIM or VEM. So those are your two types of components we deploy. So you have two supervisors and then a bunch of VEMs. Each vSphere host gets a VEM installed onto its piece of software that gets installed, and then it shows up in this switch as a module. So when I do a show module in the command line, it'll say module 1, soup, whatever, module 2, soup, whatever, and then each vSphere host is a module. One pair of VSMs can manage 64 vSphere hosts. It's like a 66-slot chassis switch. That's just what it's like. Here's a quick logical diagram that may or may not make sense, but basically what I want to show you is the VEM is installed on each vSphere host, and the VSM lives somewhere else. VSM can be deployed in two ways, right? One, and right now the most common, is a virtual appliance, an OVA file or via an ISO file. It's installed onto a vSphere server. It can be a host in the cluster that it's managing, or it can be a management cluster where it's managing some over there. I don't care. Cisco doesn't care. Whatever you want to do. The other option is a physical appliance. Network teams love physical appliances. They also don't like to have the thing that is managing my environment live in the environment. So we have what's called the Nexus 1010. It's a one-use server. You normally buy two of them, and it runs the VSM. Cool thing is, a 1010 does even more than that. It's got a NAM module. It can run things like, or will run, I can't remember which was which right now, but it'll be able to run other things like VSG, DCNM, stuff like that. So it's extendable. It's not just running VSM. So there's a lot of cool things you'll be able to do with the 1010. But in the end, management configuration is all the same no matter which one you use. So some deployment considerations, right? The 1KV is managed like a Cisco switch. So you can use DCNM to do it via GUI, but odds are at some point you got to get your hands dirty. So I always recommend you have Cisco knowledge in-house. I have done deployments in HP ProCurve environments. I've done them in, I've done them with Cisco, I've done ProCurve, and one more I'm trying to think of. But I've done Nortel. I've done them in those environments and they work great. You don't have to have Cisco switches. I recommend you have Cisco knowledge. Now, if you want to go learn it, fantastic. I just want you to understand that. You can have multiple uplink configurations. So I can have one switch, do an uplink for the DMZ and an uplink for production, VLAN 50 this way, VLAN 100 through 200 that way, and when I roll a host in, I get to pick which NICs go into which uplinks, so it's pretty slick and very unified. Virtual or physical VSMs, we just talked about that. Be a virtual appliance or the 1010, I don't care. You can absolutely run everything through the 1000v with VSMs in the same cluster. I've got a number of customers with servers with two 10 gig NICs, both of them rolled into the Nexus, with VSMs and vCenter and everything running in that environment, fully supported. We'll talk about how you do this a little bit. I got into this more in my session yesterday when I did a specific session on the 1KV. It'll be on my blog that's listed at the end. Both of these will be up there with the videos because the videos will never make it into PDF, you know, when VMware posts this. But the VEMs and the VSMs must communicate. They have to talk to each other for configuration and other information. You can do it via layer 2 or layer 3. Layer 2 just means I have a couple of VLANs that exist between them, no IP addresses. It's simple, it's easy. VLANs normally outside of a service provider are not constrained. There's also layer 3 where it uses a VM kernel IP on the vSphere host and management IP on the VSM and talks via layer 3. What it really does is creates a GRE tunnel between them and then does layer 2, but you know, it doesn't really matter. We'll talk about that quickly. Most of my deployments are still layer 2 because it's simple, easy. That's the way I've always done it, and I'm not going to change unless I have to. But there is an option. So it's a multi-step deployment. And yes, I know everything's multi-step deployment. But what I mean by that is the components that you do, or the steps are not all in vCenter. We do some things in vCenter, then we jump over to a Java GUI, then we SSH into it. So there's a couple of different places we have to go. So we're going to deploy a VSM. We're going to then perform basic config. We're going to deploy the second VSM, which we don't really config. It just replicates the config. And then we create our uplink and our port group configurations. And then just as before, we roll hosts and VMs over. So it's not fun to talk about. It's a little bit more fun to watch. So the step one is real easy. If you've ever deployed an OVA or an OVF file, you do file new in OVA. OVA and OVF are just packaged up VMs that can be deployed as a standard format. An OVF file is just a VM. It plops it out on the data store, configures it, and that's it. An OVA file lets it ask some questions for the deployment and script some things. So that's what we normally use as the OVA. And it's going to kick off a basic configuration dialog. So it's going to tell you a little bit. It's going to use 3 gigs of disk space, thick provisioned. Do not thin provision this. 3 gigs of disk space. I think it's 1500 megahertz CPU reservation and 2 gigs of RAM for each VSM. So we say, okay, we give it a name. Do not name it VSM active and VSM secondary or primary and secondary. You never know which one will be primary and which one will be secondary. I named them VSM1 and VSM2, but use your imagination. The next question is, what type of configuration? There's 3 options here. First of all is the 1000v installer. That's going to walk you through some steps to do basic config. The second option is Nexus 1000v secondary. That's what we'll use for the second VSM. You answer 2 questions, and it goes ahead and deploys it, and then they talk to each other and replicate config. The third option is 1000v manual. If you've ever deployed or booted up a new Cisco switch, you walk through that text-based management configuration. All right, that's what this will do, and the rest is up to you. All right, that was the original deployment method. I don't use that anymore because the GUI method works. It didn't used to really work. Now it does. But if for some reason you want to do manual completely, you can do that. So we hit next. Then it's going to ask us which resource pool or cluster we're going to deploy these to, which I don't really use them except for my vCloud. Storage, we're going to put the primary, I did it. We're going to put the first VSM on one data store and the second VSM on another data store. You don't want to put them on the same data store because if you lose a data store, what happens? I just lost most of my VSMs. Next, and I know I'm flying through this, I'm sorry. Next is network configuration. So I said a minute ago the layer 2 configuration uses a couple of VLANs. It uses 3 VLANs to be precise. Management, control, and packet. Really quickly, management is what I SSH into to get to the command line interface. It's also what the interface or IP it uses to talk to vCenter for pushing up config changes. Then you have control. Control is what the 2 VSMs use to talk to each other for config, and it's what the VSM uses to talk to the VEM to push down configuration changes. You have to trunk the VLAN all the way across to all your vSphere hosts. And if you have a 1010, it needs to go over there. This is the #1 problem I see in the field in deployments. People don't trunk it. They think they did, or they miss it between 2 switches, or a customer will kind of lie to you by accident. But if you deploy 2 VSMs and they don't see each other and they both think they're active with no standby, it's your control VLAN. If you bring up your vSphere host with the VEM and it doesn't sync up to the VSM, it's your control VLAN. I guarantee it. The last one is packet. Packet just carries information, mainly CDP and port span. If you do ER span or span, that's the VLAN it goes over. Completely supported to put all those on one VLAN. Do not use VLAN 1. Why? Because VLAN 1 in a Cisco environment is all over the place. It will use broadcast frames. What happens if I broadcast frame those? It goes everywhere. The next thing it asks you is domain ID. If I have multiple deployments of the 1KV sharing VLANs, they need to know how to stay separate. That's your domain ID. Pick a number, make sure it's unique. And then basic information like what do you want the admin password to be, what do you want the IP to be, subnet, gateway, things like that. So this is going to boot up the VSM into a basic state. We'll go ahead and say deploy, and we'll watch it boot. And after it boots, we're going to go to a web browser, and we're going to point the browser to the IP of the VSM we just deployed. And it's going to come up with, of course, a web page, right? There's 3 things on the web page. The top link is launch installer, launch Java installer, something like that. It launches the installer that does the next piece of the configuration. That's what we'll use. The second link is an XML file. That XML file, think of it like a certificate. It gets installed into vCenter as a plugin. That's how vCenter trusts that VSM over there. It's generated on deployment. That way you can't have a rogue VSM just willy-nilly changing port groups all over the place. If you use the Java installer, it automatically installs that XML for you. It's just there in case you need it. The third thing you'll see is a matrix of build numbers and VEM versions. It used to be in, before 4.1 Update 1, you had to match kernel build of the vSphere host to the right VEM build. Now VMware uses this monolithic kernel support where we only have to worry about that. Like there's one build for 4.1 Update 1 and all the patches. There's one build out there for 5.0. It's greatly simplified. So we'll see this boot. And if you've ever seen a Nexus switch boot, it looks pretty much like that one. So after that, we'll go ahead and load the web page. One thing you'll notice in a minute is when we go through the Java installer, it's going to ask you some questions you've already answered. And this confuses a lot of people. They think they've done something wrong. They think they've made a mistake. That's not true. Think about this. What if I'm in an organization with a network team and a server team? Who's going to deploy the OVA? The server team. Who's going to do the rest of the configuration of the 1000v? Probably the server team. Or, I'm sorry, the network team. Server team's going to deploy the OVA. Network team will do the rest of the config. You may set a basic password when you deploy the OVA, and the network team wants a password this long, and that's what they set. So don't be surprised if you're the person doing both pieces of this that you're answering questions you've already answered. That's very normal. It's expected. So the switch is now booted. You'll see that when you get the login. Just like an iPhone commercial, most of these things have been sped up. You can't install it this fast. And now we'll go down and load Internet Explorer and start Java. You need Java, I believe it's 1.6. I hate Java, but it kind of works. There's the web page with the installer at the top, the XML, and then the matrix down at the bottom. You don't really worry about the matrix these days because we do most of the Vim deployments via VMware Update Manager. As soon as you roll a host in the environment, VUM will push the correct build of the Vim down to it. That's my suggested method. You can do manual installs, but if you have VUM, use VUM. So here's the wizard, and it's going to ask you some questions that it's already asked you. First, it needs to know the login for the VSM. Then it's going to ask you for your vCenter IP and login to install the XML file that we just talked about, that certificate file. And down at the bottom, if you've already configured one of these, you can save all these answers to a file and load it right there. Next, it needs to know the VSMs, which VM the VSM is running on. Why? Because it lets you change the network configuration in this wizard. So if you want to go to layer 3 or you want to change the layer 2 configuration, you can absolutely do it in this wizard right here. So you have 3 options. Up at the top, I don't know if you can read that back there, is default layer 2. That means I'm going to use the management VLAN for all 3 things. So I'm just going to leave it. The second option is I'm going to use 3 different VLANs for the 3 things or some combination. And if you're like me and you get in a hurry and you forget to build the port groups for that before you run through this, it lets you build them right in here. And the last one is if you want to do that layer 3 configuration with IP connectivity, you set that at the bottom. For my lab and my demo, I just do default layer 2. I'm lazy. And it works. But there's it. You can go each one of those and create them or pick a different port group. And then for layer 3, you can set some IP information. So go ahead and continue. Here, we're saying things again. Switch name. What do you want to show up as in vCenter? And then re-enter in a new admin password. It can be the same or it can be different. IPs are good. System redundancy. So remember, you don't license the VSM. You license your host. So there's no reason whatsoever, ever, to deploy a single VSM. You don't pay more money for 2 than you do for 1, even if you buy 1 socket of licensing. So set that to primary, and then we'll deploy the secondary. You'll reset the domain ID, and finally, if you use a native, or whatever your native VLAN is for your environment, you'll just go ahead and punch that in there. If you want to enable Telnet, because you don't have a security group that'll come out and whack you on the hand with a ruler, you can enable that there, but most people don't. And so it's going to do a bunch of stuff right here. It's going to reboot the VSM twice. This takes like 5 minutes. Now, I'm not going to sit here and make you watch check marks for 5 minutes. So what we're going to do is we're going to jump over while this happens and deploy the second VSM, and I'll show you the slightly simplified workflow. So again, new OVF. We pick the same file. The only difference is we pick that 1000v secondary option on the first menu item. Come on. Blah, blah, blah. Kept my same path. Same. Make sure you read that, by the way. You never know. I probably owe my soul to Apple. So I picked secondary. Now, I'll pause it here for one reason. Everybody misses this. I missed this. Down at the bottom when you pick secondary, it's got this paragraph that nobody ever reads. And what it says is, if you choose secondary, exclude questions C through E. Why they don't just say answer A and B, I don't know. But you're also going to notice me in a minute, I actually fill out A through C. But it used to be people would fill them all out and it would apply it and it would actually cause problems with the secondary VSM. So just pay attention and know the only thing you really have to enter is your domain ID and your password. So if the network guys who deployed the second piece of this change the domain ID, make sure you know that or they're not going to talk. Pick your data store. Pick a different data store. Yeah. If your network admin changed the VLANs that he's using, make sure they match here or they will not talk to each other. It's the same screens you saw before. Domain ID, password, and don't pay attention to the guy who answered the third question. I don't know. I mean, I've asked that question 20 times. So we're going to go ahead and deploy this guy just like we did the last one and power it on. And what I'm going to show you at the end is, like I said, I don't use GUI, so I'm going to SSH in and use command line like a real man and show you that. I don't mean that the wrong way. And I'll show you how these two come up and look like modules. And a lot of times it really clicks for people, especially network admins, when we get to this point and they go in and they start issuing Cisco IOS and XOS commands and they see this as modules. And then it starts to click as to what they're doing. So the primary is finished. He is good to go. And we'll click next. Right there is where you could save it will also let you do a migration of a host right then over to the DVS or the 1000v. Problem is we haven't done any configuration. We haven't done uplink. We haven't done port groups. We haven't done anything. So it's probably not a good idea to do that right now. And what I want to show you here is if we go click on the summary page here in just a second, you don't have any options, right? The only thing you can do is roll a host into the switch from vCenter. We click summary. There's no settings for creating port groups or anything. Nothing is done out of vCenter. It's all done either out of DCNM or the CLI. So here's PuTTY. I jump onto the IP, blah, 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 PuTTY, admin and password. I hope you guys can see this. If not, it'll be on my website. Up at the top, you're going to see Module 1, VSM, active. Module 2 is powered up. I'll give it a second. And it'll show HA standby. That's good. HA standby is good. Why is it good? It means my control VLANs are trunking correctly. One trick is, if you're not sure your control VLANs are right, vMotion the VSMs to the same host. If they all of a sudden work, it means they're talking internal to the host. If they don't work on two separate hosts, it means your trunks aren't working. And there we show active with HA standby, so that means your initial deployment is solid. So the next thing we do is create port profiles, and I'm running out of time. So there are two types. One is your uplink configuration. This is type Ethernet. In the 1000v, if I say Ethernet, it means physical. Okay? It usually means the port plugging in the back of the vSphere host. If I say vEthernet, it's virtual. That's why there's a V in front of it. And that usually means either a port group that shows up in vCenter, or it's a VM's NIC, which gets a vEthernet number. So here is what you type in to create an uplink configuration. So you SSH into the switch or use DCNM. You go into config mode and you type port profile type Ethernet, physical uplink, name, prod uplink. The name is case sensitive. If you come back in to make a change later and you type Ethernet, lowercase prod uplink, you now have two uplink port profiles called prod uplink. So pay attention to that. The next command is VMware port group. They changed my letters. That's supposed to be all lowercase when they ran the review. Okay. Anyway, it's VMware port group. Defines it as a port group. You can say VMware port group and another name, and the name will show up with that in vCenter, but show up as a different name in the 1K vconfig. Don't do that. You're just going to confuse yourself. But type VMware port group. Cisco people, switch port mode trunk. We are trunking VLANs over these connections. So it's switch port mode trunk. Switch port mode trunk allowed VLAN. I'm doing 5. You could do all. You could do a range, whatever you normally would do. Channel group auto mode on MAC pinning. That's a fancy word for I'm going to do load balancing based on MAC hashing. I don't get into this here. I don't have time, unfortunately. I did yesterday. So download that presentation. But it talks about all the different types of support like LACP and things that you can do with the 1kV. But there's a lot of options, a lot of cool options for how you can do load balancing. No shutdown just means bring this profile online. System VLAN 5. What happens when a vSphere host boots up and it hasn't talked to the VSM, it doesn't have config information, but it needs to do something like NFS or iSCSI? You got a chicken and egg problem. Or control VLAN. It needs to get its information from the VSM, but it doesn't know how. System VLAN 5 says, if I see a frame tag for VLAN 5, ship it out this uplink. Just do it. Don't ask questions. Don't worry about it. Go. Just do it. So what do you want to do for that? I'm going to say these fast, and people are going to try to write them down, but it's in my list. Control, packet, management, NFS, iSCSI, FT, and vMotion. All of those should be set as system VLANs. Then state enabled. When you type state enabled, it pushes it to vCenter, and you see a bunch of tasks happening. This is what you're probably going to do most of all. Whenever you want to create a new port group, these are what you type. So it's the same port profile command with type V Ethernet. That means I'm doing a port group config. Same VMware port group command. Max ports. Remember when we talked about ports in the VDS and 128 was the default? The default on the 1kV is 32. I don't know why it's 32, but it's 32, and everybody freaks out and calls me when they try to boot up that 33rd or connect that 33rd NIC. So go ahead and set it to something more reasonable. Switch port mode access. So if you think about it, if the VM is not tagging frames like most VMs don't, then we're plugging them into an access port on a switch. So switch port mode access. We tell it which VLAN that access port belongs to, and then we do a no shut. System VLAN 5. System VLANs must exist in both places or they will not work most of the time. So if you do system VLAN 10 on one, you'd better have a port group that also says system VLAN 10. If they're not in both places, I can't guarantee it's going to send those frames. This becomes very evident when your VSMs don't talk. You forgot to put control in the system VLAN configuration. And then state enabled. Deploying the VSMs, or VEMs, goodness. Deploying the VEMs to each vSphere host is easy. Use VUM. Use VMware Update Manager. When you roll a host over in vCenter, it will auto-deploy that correct build of the VEM to the host. If you're crazy and you don't want to use VUM, which you're not too crazy if you don't use VUM, but if you don't want to use VUM, you can do manual installs. You can download the correct build number, move it over, and use like the ESX CLI software command that's now in 5, or just use the ESX update command in 4.1. But either way, I do VUM. VUM can also be used to keep the VEMs upgraded when Cisco patches them, so it's a really good idea. I'm going to skip this real quick. This was basically showing a deployment of a host into the 1000v. It is exactly like doing it on the VDS. All you do is, actually I'm going to jump to the end and show you something. You go in there, you right click, you add host. It's just like the other. What I want to show you is, come on. You jumped on me. So this is a show modules command. There, finally. Module 1 is the VSM. Module 2 is a secondary VSM. Module 4, because I already had a 3 in my lab, is that vSphere host. He will always be module 4. So he looks like a module in the switch. Down at the bottom, you see the list. You see my server name, which is Bumblebee. I'm a big Transformers fan, so his name's Bumblebee down at the bottom. So that way you can easily see which module is each vSphere host. Then I do a show interface brief. What I want you to see, I did it again. Show interface brief. One thing I want you to understand is that each VM NIC gets an interface number. Stop it. This is why I don't like doing videos and I prefer to do actual live demos. So this is a picture of show interface brief. And what I want to see is right here, I don't have my pointer up here, on the highlighted line is vEthernet 1. I rolled a VM over when I rolled the host over. So I picked that VM, View XP, I believe that's what I did, and roll the VM over. The first VM that shows up gets Ethernet 1. The second one gets 2, 3, 4, 5. VM kernels also get the same. They kit that number until they're deleted. So if I wanted to apply an access list against a VM NIC, I apply it against the Ethernet interface. No matter where you vMotion the VM, no matter if you power it down, power it up, whatever, he's always Ethernet 1. Those policies still apply. And if you're a Cisco guy and you want to do a show interface, Ethernet 1, is that just me, or does that look like an interface on a physical switch with all my counters and my errors and any problems? Those keep going. A vMotion doesn't clear them. Up at the top, it'll tell you owner is VM VXP1. Adapter is network adapter 1. Active on module 4. We know which vSphere host module 4 is. We just did a show modules and saw it. And then it gives you the port ID, and the port profile type is VLAN 5. I named that vEthernet port profile VLAN 5. So it's all matched up right here in one place. So this is the power from a Cisco person's perspective. It's like a catalyst. When I plug that VM into that NIC port, it's always on that port. Any QoS, any access control list, any policies, they follow it no matter where he floats in the cluster. Does that make sense? Yes. Recommendations. Always deploy VSMs in pairs. I've already told you that. There's no cost. Deploy on different data stores. Use anti-affinity as needed. If you use storage DRS, keep the VMDKs apart. You're not supposed to allow DRS to move the VSMs around. You can vMotion them manually. Cisco just says if all of a sudden DRS spazzes out and starts moving VSMs back and forth, you can start dropping frames and disconnect the VMs. Okay? So they say to exclude them from DRS, but you can absolutely manually vMotion them if you need to put a host in maintenance mode. Not a problem. No clones, no snaps. Don't do clones and snaps. Don't back up the VSM. Back up the config like you would any other Cisco switch. Whatever you use, point it at it, let it grab the config. You can redeploy a new VSM a lot quicker, and you're going to restore that VM. And you don't want to have to worry about weird version changes between it and your vCenter configuration database. Fully supported to run everything through it. I've already talked about that. MAC pinning is the simplest method, and it's the most recommended. Why is it the most recommended? It works everywhere, and you don't call TAC and bug them. So that's why they say that. If you have stack switches, VSS, VPC, all other cool stuff, you can do more fancy load balancing. It's very supported, LACP, things like that. But MAC pinning, just like in vSphere, works really well. I already said don't back up the VM, just back up the config, and run the latest code. I have a lot of Cisco customers that would not run the latest iOS or NXOS with a gun to their head, okay? They always stay at least one rev back. It's not that I want to scare you, but the current latest versions are stable, and as I've talked to the Nexus team, they've been tested to the extremes. They've had all the features turned on. They've scaled to the limits. They've done this, they've done that. They're very well tested. There were bugs in earlier builds. I've got my name on probably 4 of them. So it's not an issue these days, but right now, you want to be out there. If you deploy this tomorrow, you want to deploy 1.4a. Okay, that's the latest version. That's what you want to deploy. And I recommend that your VEMs and VSMs stay current together. Some people, it's supported to have a VEM back level 1 version. Just keep them and roll them up together. The upgrade process is very smooth. VUM will help you. It's easy on the VSM. Keep them together. A couple things to watch out for really fast because I'm about out of time. I've already talked about it. Primary and secondary VSMs don't talk. It's control VLAN. If you're using layer 3, just do a couple of pings because something's not routing correctly. That's one reason people like layer 3 configs. Usually it just works easier. Cisco has a great troubleshooting guide now. It's kind of like those old choose-your-own-adventure books as a kid. Run this command. If you see this, go step 4. If you see that, go step 8. So it'll walk you through it. At the end, I'm going to have a link to Louis Watta's Cisco Live session on troubleshooting. It's 90 slides long, and he does it in 2 hours. I can't give any sort of depth like that. I don't want to scare you and think, holy man, I don't want anything that takes 90 slides to troubleshoot. Louis is just awesome, and he walks you through everything. So take a look at that if you're going to do a deployment. And finally, let's recap. I'll talk if anybody wants to write down Lewis's link. I want you to understand what the differences are between the two, and then I want you to look at and talk with your network teams and see what kind of features they need. Especially look at what the capabilities are going forward. Things like on the 1KV with VWAS, virtual ASAs, VSG, stuff like that. But also take a look at how simple the VDS is and some of the really nice features that VMware's been putting in it. So it's kind of a tough thing to make recommendations. Usually you need to look at your requirements, look at your design, look at how you manage your environment and who's going to be doing it, and then figure out what meets your goals the best. But I want to thank everybody for coming out for the last session. I hope it was good. Please fill out a survey if you can. I'd appreciate that. They're very important. And I'm going to be here for a while up front, or if they kick me out, I'll be in the back. And I'm happy to answer questions since I think we're out of time. But thank you very much.